Hello students, in today's class we will read about the electric current in conductors. Electric current in conductors. So first of all, I want you to know what is conductor and how conductors have the ability to help this electric current to pass through it, whereas we will see that the other thing which is known as semiconductor and insulator, they do not have this ability to flow the current via them. Only conductor have this ability. And why these semiconductors are called semiconductor? Because they show some properties which are similar as conductors, and it basically depends upon the chemical composition of these semiconductors. So I'll give you the brief summary about the semiconductor and insulators so that you will have this idea how the conductor, insulator and semiconductors differ, and how this electric current is flowing in the conductors, less flowing in semiconductor and least flowing in the insulators. See over here, when we are talking the same thing in chemistry, we name them differently. We name it as metals, metalloids and non-metals. See, these three things also signify same as conductor, semiconductor and insulator, but thing is that few non-metals do behave like conductors and few metals do behave like insulator. But in brief, in general, they can be equalized, but they are never the same. Metal, metalloid and non-metals are quite different from conductor, semiconductor and insulator, but are same sets. Okay, so we will start with the theory. One of the very famous theory is valence band and conduction band theory. This valence band and conduction band theory gives us a very generalized and very straightforward idea how the conductors are conducting, while the semiconductor and insulator are least of the conductors. So in this valence band and conduction band, we have two bands. One is the conduction band, I'll write it as CB, and other one is the valence band. You have seen one atom. This atom have a nucleus, and in the orbit we have electrons revolving around it. So these revolving electrons, if this is our nucleus, electrons are revolving in these orbits. Okay, so these electrons travel from the ground energy level to the above energy level. So they have this ups and downs from a ground state to excited state and vice versa, during which they release energy. So one more thing is that when we are talking about the atoms, smaller atoms like when the atomic number is less than 30, in that case atom is said to be small, and in this case the nuclear forces specifically is the Coulombic force between the nucleus and electrons is high. But similarly, when we go from 30 to above, when Z is greater than 30, or greater than 30, in this case there are few factors which make the electrons in outermost The electrons in outermost orbit behave like unbound electrons. Unbound electrons. So these behaves like unbound electrons, though they are bounded electrons, but they can move freely. When they have this ability to move freely, they conduct electricity. Or they help in the passage of electric current. The motion of charges is allowed. Move freely. What is moving freely? Electrons are moving freely, and the motion of electrons is producing electric current. So this is one theory. Another one is this, our conduction band and valence band. See, if I say this is my valence band, for the metals, for conductors, our valence on the valence band, we will have the conduction band CB. They are doing what? They are overlapping each other. Overlapping conduction band and valence band in case of conductors. So motion of these electrons from the conduction band to the valence band is like favored. There is no need of excessive energy. No need of external energy for electrons to move from CB to VB. Okay, so when there is no energy, the flow is favored, and hence the flow of electric charges and electric current is favored in conductors, and they complete a circuit. Now we will see the case of semiconductors. Group 14 make semiconductors, and these group 14 are doped with group 13 and group 15. According to that, they are classified as trivalent and pentavalent. In this case, what exactly happens is, if this is the valence band and this is the conduction band, the energy gap between these two is equal to or smaller than 3 electron volt. Eg is energy gap, which is equal to or smaller than 3 electron volt. So if the electron in the conduction band is able to gain energy equal to 3 electron volt, this can jump over from conduction band to valence band. So to provide such kind of energy to the electrons in conduction band, we need to dope the semiconductor with group 13 and 15. Doping is called addition of impurity, addition of impurities also. The concept of semiconductors is clearly explained in chapter number 14 in our class. So when we are going to read the chapter 14, I'll give you the extremely clear idea. This is just a preview. So it should be less than 3 electron volt, and in such a case the electrons will be able to move. If there is excessive electrons in it, if we are doping, providing impurity, this says there will be more than the natural number of the electrons, which will create the kinetic energy inside the conduction band, which will provide the energy for these electrons to jump over the energy gap and reach the valence band, and in such a case they will start conducting electricity. So doping is necessary to make a semiconductor into a conducting bodies. Now when we read the case of our insulator, if this is our valence band, this is our conduction band, the difference between valence and conduction band, the energy gap is quite greater than 3 electron volt, and it insulator needs a lot of external energy, lot of external energy to like to travel from CB to VB, like to jump from the conduction band to valence band. So it is quite tough for us to provide this much energy. If we start providing this much energy to the electrons present in conduction band, then what will happen? Our work done on the insulator will be higher and the efficiency will reduce. So this is the basic justification how do the conductors conduct electric current. Now we will move on to our concept, that is electric current in conductors, and we will see how we are defining what are the following laws which help us to understand these principles. So electric currents in the conductor. See, an electric charge will experience a force if an electric field is applied. Like if this is our electric charge, let's assume electron is the electric charge, and if we provide this electric field to this electron, there will be a difference in its spin. If it is moving like this, it will try to orient it towards positive. If this is like positive, negative, this will try to orient towards the positive. Okay, so if we are providing electric field, it will definitely feel a charge and feel a force. Force and the electric field are related like this. Force equals to Q into E. That is, force is given by charge, product of charge into electric field. Force is given by charge, product of electric field. Okay, so if it is free to move, contributes to current. If these electric charges are free to move in this given electric field, they will start generating the current. The current will follow up. If we are providing this electric field and this electron moves upwards, downwards, or at some angle, in that direction, in whatever direction it moves, it will contribute to current. Direction of current equals to direction of motion of electron. Okay, now in our atmosphere there is a layer which is termed as ionosphere. This ionosphere is a layer of atmosphere, and here free ions exist. So these free ions, when they are provided some force or the electric field, they will form the currents. So our Earth's magnetic and electric field do contribute, and you will find some sort of some very small range of current flowing in it, and whenever thunderstorm happens, the ionosphere's ion contribute in these thunderstorms. Now in an atom and molecule, negatively charged electron and positively charged nucleus are bound, not free to move. So as I have told, this is nucleus, this is electron. In smaller, they have Coulombic attractions or Coulombic forces attracting on them. Coulombic forces acting on positively charged nucleus and negatively charged electron. Okay, so they are not free to move. But as soon as we go to the higher atomic number molecule, we will see that the outermost electron is quite free to move. If we provide a slight energy to that last electron, or in the electron in the last orbit, it will jump out of its orbit. Now conductors. Conductors are the material having some electrons which are free to move in bulk material. Develops electric current in them when the electric field is applied. Electric field is applied. So if I see this is one of the conductor I am having, okay, and now the electric field is provided to this conductor, the free electrons in this conductor will start moving against the direction of electron will move against the direction of electric field. Okay, they will start moving and they will form the current layers. Okay, now types of conductor. We have different types of conductors. Conductor is something which conducts. It's not just solid. Okay, conducts electricity or heat. Conducts electricity or heat. Okay, so there are solid conductors, in that only electrons can move, whereas electrolytic solutions where both positive as well as negative charges can move. Now what is electrolytic solution? Electrolytic solution, electrolytic solution. So these electrolytic solution are made by electrolysis, by the process of electrolysis, process of electrolysis. What exactly happens if we have this CuSO4 or zinc sulfate, something like that, and we have solubilized them, what will happen? They will form ions, both positive and negative ions, and these positive ions will move from the inside this solution from here to there. So this motion of positive and negative ions will help in the formation of current, in the motion of current, or in the conductance of the current. Conductance of the current. Okay, now our focus is on solid conductors in this chapter. We will not go to electrolytic solution. In chemistry we will be deeply reading electrolytic solution, but in physics we aim at solid conductors because all our electronic equipments have these solid conductors in it. You have seen the motherboard of your computer, you have seen the motherboard of your mobile phone, everything is in the solid form. So the physics deals with all these electronic items where the solid is the main focus. So we will be dealing with the solid conductors where only the electrons can move, and the protons are having a fixed position. So whenever we are dealing here, whatever laws we will be reading, resistivity, resistance, conductance, conductivity, everything will be only and only for the solid conductors. Here we are having the two cases. Case 1 where there is no electric field is present, and case number 2 where we have introduced the electric field. So where do we are introducing the electric field and where we are not introducing is the conductor. See, this diagram is showing a conductor. This is a conductor, and in case 1 this conductor is simply kept. There is no existence of electric field, no E. But in this second case we have this conductor which is actually placed in the electric field. There is electric field. Here electric field is not equals to 0. Okay, so what are the different kind of motion of electrons in the presence of electric field and in the absence of electric field is what we are going to see in this case number 1 and case number 2. So let's get started with the case number 1. Electrons will be moving due to thermal motion, during which they collide with the fixed ion. An electron colliding emerges with the same speed as before the collisions. Velocity after collision is completely random. Therefore, number of electrons moving forward equals the number of electrons moving backward. Hence, no net electric current. So these are the points which are extremely important to understand. Okay, so I'll explain what exactly is happening in case number 1. Suppose this is the conductor C and there is no electric field. No electric field. In such case, the electrons present on the surface of this conductor which are free to move on the surface itself, free to move on the surface only. They are not supposed to move out from the conductor but can move inside the conductor only. The motion inside the conductor of electrons is free. Now, these electrons will move. How will they move? They will move in random motion. Random motion. One electron will go here, one will go here, one will go here. So this is random motion. In this random motion, they will collide. They will collide with each other. So velocity before collision equals to velocity after collision. Because they are randomly moving and we do not know in which direction did this electron move. It can be this direction also. So overall, if we see, the electron will seem to have the same velocity. Hence, the energy they are having, the energy of the system. See, the velocity of individual electron will change, which will change the energy of individual. But energy of system before and after collision will remain same. Before and after collision will remain same. Will remain same. Individual will change. Individual velocity may change. Okay, individual velocity may change, but energy of the system, not the velocity, sorry, it should be energy. Individual energy may change, but the energy of system will remain same, constant. Okay, constant. In such a case, what will happen is that number of electrons moving forward will be same as number of electrons moving backward at every point of time. Number of electrons moving forward equals to number of electrons moving backward at all the time interval. So in such a case, there is no net flow of charges. When we see net flow, net flow seems to be zero. So there will not be any electric current. So there will not be any electric current because the net flow is zero. Now we will see the case number 2, where our conductor is placed here, which is having electrons on its surface, and now we have provided the electric field to it. Okay, we have provided the electric field to our conductor. When electric field is present, conductor in the shape of cylinder of radius r. This radius is r. From this center to the surface is r. Took two thin dielectric circular disc of same radius, and we have taken the two discs like this, disc number 1 and disc number 2. See, this point which you can see over here is the disc we have attached. This disc will provide the electric field needed. Okay. So, took two thin dielectric circular disc of the same radius and distributed plus q and minus q charge equally on both the discs. See, disc A1 is having plus charge and disc 2 is having negative charge. So charge on disc 1 equals to charge on disc 2. But what is different? The sign is different. Disc 1 is having positive charge, disc 2 is having negative charge. Now the two discs are attached to the flat surface of cylinder. They are attached on this flat cylinder surface of this cylinder. Now we will see what happens next. An electric field will be created and is directed from the positive towards the negative charge. See over here, I am making the diagram once again. This is positive, This is negative. So the charges will move from, the electric field will move from positive to negative. Okay. These charges will create, the dielectric containing the charges will create a electric field along the conductor. See, I will write this point over here. Dielectric present at the end of cylindrical conductor containing positive and negative charges makes the electric field. Makes the electric field. So these dielectric will be producing the electric field inside this conductor. Now what will happen? This field will be directed from positive direction to the negative direction. Electrons will be accelerated due to field towards plus Q. Now electrons are negatively charged. Electrons are negatively charged. Hence, they will get attracted towards disc 1 containing positive Q charge. Okay. Now electrons will move to neutralize the charges. Motion will constitute current, will be of very short duration. We can provide charges externally to make up neutralizing charges, which will result in steady electric field inside the conductor. As a result, we will flow the current continuously. Mechanism will maintain steady current are called cell and batteries. Now over here the points needs to be understood very clearly. I'll explain the process in a summarized way, so pay attention to it. First of all, we got a conductor which is cylindrical in shape. Second thing we did, we brought disc 1 and disc 2 containing plus Q charge and minus Q charge, and we added this disc 1 and 2 at the circular end of the cylindrical conductor. Then this disc D1 and D2 started behaving like the ends and induced the electric field. Electric field is directed from plus Q to the minus Q. Now inside the conductor were the electrons. These electrons, being negatively charged, started getting attracted towards the positive Q disk. So overall, if we see, there is a net flow of current seen. Net flow of current which is observed. This current is short-lived because number of electrons are limited. Short-lived current, as number of electrons are less or limited. So in case if we want this current to continuously keep on coming, if we want continuous current, we can add the electrons from the outside. So these electrons will again start neutralizing the whole system and will tend to move towards the plus Q charges. They will also tend to move towards these plus Q charges disk. So as these charges unlimitedly in a very huge amount are coming from outside, they will create a steady current, will give rise to steady current. So this is phenomena how the current is being generated and is used in our day-to-day life. One of the best mechanism where we can see the flow of steady current is the cells and batteries, which we use in remote TV remotes. We use these in torch. We use it in various other equipments, electrical equipments. Our calculator have these cells and batteries. Calculators, watches, let it be wristwatch or our wall watch, anything. So in these cells and batteries provide continuous electric current, which make this remote, torch, calculator and watch, all these electronic items to keep on giving us the accurate information and keep on working. They will mechanically be very okay. So this is how the charges are being conducted, and the element or the substance which is conducting the charges is called a conductor. A conductor. Conductor behave differently in the absence and in the presence of electric field. In the presence of electric field and in the absence of electric field. In the absence of electric field, there is no net electric current flow. Electric current is zero, net. Whereas in the presence of electric field, there is a net electric current flow due to the motion of negative charges towards the positive end of the electric field. Okay. So this is the mechanism, and the flow of the current is seen as steady flow. This is observed in the cells and batteries which are used in the electrical equipment. So in next class we will see another new and interesting topic which gives us relation between voltage, current and resistance. We will see what is resistance and will see more about it, and that particular process is known as, that particular law is known as Ohm's law. It is a very extremely, I'll say, important topic for us to learn. That is like the heart of the electric current topic. So for today's class, that's it. We'll meet in the next class with another interesting topic. See you then. Have a good day. Bye bye.